Hello, we are Group 9. We'll be presenting our mini project of electroplating, and our team members consist of me myself as Auldrey Angal, Nazhatul Shima, Muhajir Akmal, and also Muhammad Asyraaf.
Electroplating uses redox reaction where copper atom lose electron, producing copper 2 plus ion. This electron enter the electrical circuit and go to the cathode, which is nail or key, during the plating process. In nickel plating, a copper stick acts as a sacrificial anode, depositing a solid copper layer on a iron nail. In contrast, in nickel-plated brass key, copper 2 plus ion gain electron from the copper sulfate solution, forming a solid copper layer on key. In summary, electroplating is a crucial process for creating decorative finishes and corrosive protection by depositing a thin layer of metal on conductive surface.
The introduction of our mini project was electroplating is the hydrolysis-based process of plating one metal to another, usually for aesthetic reason or to stop a metal from corroding. Additionally, there are distinct varieties of electroplating such as chromium, silver, and copper plating. The objective of our mini project was to determine the effectiveness of different solutions as electrolytes in electroplating process, and the second one is to illustrate the fundamentals of chemical reaction.
Okay, equipment for this experiment is crocodile clip, 9 volt of batteries, beaker, analytical balance, and sandpaper. Meanwhile, for materials, 0.1 molar copper 2 sulfate, 0.5 molar hydrochloric acid, key, copper, and iron nail. First, clean the key with sandpaper. Second, weigh the initial weight of iron nail, copper stick, and key. Third, set up the experiment as in the video. Make sure that iron nail and key are on positive electrode, meanwhile copper stick at negative electrode. And soak electrode in 0.5 mol of 5 ml of HCl. Fourth, positive electrode is key and negative electrode are copper stick. Then soak the both electrodes in 0.1 molar of 50 ml copper 2 sulfate plus 0.5 molar of 7 ml hydrochloric acid. Observe the change in reactions. Fifth, repeat the experiment with iron nail at positive electrode while copper stick at negative electrode. Soak both electrodes in the 0.5 molar of 50 ml hydrochloric acid. Observe the change in reactions. 6. Remove and dry all the materials with tissues. 7. Weight the final weight of materials.
For part 1, iron nail act as cathode while copper stick act as anode. The solution that have been used was 15 ml of 0.5 molar hydrochloric acid. Mass obtained at the anode is decreased since it undergo oxidation, while mass obtained at the cathode is increased since it undergo reduction. At the cathode, the initial color of iron nail was silverish grey due to iron coating, while final color was brownish black due to dissolution of iron and the formation of hydrogen gas. At the anode, the initial color of copper stick was reddish brown due to characteristic color of copper oxide, while final color was reddish brown due to dissolve slightly. As for the solution, the initial appearance was clear, however it becomes slightly cloudy during final appearance due to evolution of hydrogen gas bubbles. For part 2, copper stick act as an anode while nickel plate brass key act as the cathode. The solution that have been used were 15 ml of 0.5 molar hydrochloric acid added with 7 ml of 0.1 molar copper sulfate solution. Mass obtained at the anode is decreased since it undergo oxidation, while mass obtained at the cathode is increased since it undergo reduction. At the anode, the initial color of copper stick was reddish brown due to characteristic color of copper oxide, while final color remains slightly reddish brown, but it might show sign of dissolving. At the cathode, the initial color of nickel plate brass key was silverish white due to nickel plating, while final color was reddish brown because the nickel plating covered by layer deposited copper, giving reddish brown appearance. As for the solution, the initial appearance was light blue due to copper sulfate solution. However, at final appearance, the solution developed slightly darker shade due to depletion of copper ion from copper sulfate as they deposited on cathode. For the equation, at the anode, copper solid undergo oxidation gave copper ion as production, and at the cathode, copper undergo reduction gave copper solid as production.
Assalamualaikum, my name is Muhajir Kamal and I will discuss the result and conclude this mini project. I will start with the cell that use copper sulfate as electrolyte. In the cell, the Cu2 plus ions from copper sulfate and H plus ions were attracted to the negative cathode, which is the key, but only the copper ions were reduced to copper metal and deposited onto the cathode. HCU2 plus ion gains 2 electrons transferred from the anode direction when reduced. On the other hand, negative ions such as sulfate from copper sulfate and the traces of hydroxide ions from water were attracted to the positive copper anode. But the copper anode is favorably oxidized in electroplating when supplied with power from the battery to discharge ions into the electrolyte solution instead of sulfate ion and hydroxide ion. Basically, the copper metal from copper ions in the electrolyte is coated on the cathode. Simultaneously, the metal of the anode is oxidized to replace the copper ions in the solution, which both involve electron transfer. Theoretically, when copper sulfate is electrolyzed with copper anode, the copper deposit on the cathode equals to the copper dissolved at the anode. Therefore, the blue color of Cu2 plus ions stay constant because the copper deposited is equal to the copper dissolved, as there is no depletion of copper ions concentration. That's why the gain in mass of the cathode is about the same as the loss of mass from anode for both electrolytes used in this experiment. We will move on to the observation. When we compare both electrolytes used in electroplating, the lower weight changes in anode and cathode observed with hydrochloric acid compared to the copper sulfate, which are primarily due to the differences in copper ion availability in solution. Copper sulfate provides a consistent and high concentration of Cu2 plus ions, essential for the efficient copper deposition onto the cathode. In contrast, HCl also showed the oxidation of copper anode, but doesn't sustain the supply of Cu2 plus ions in solution, resulting in lower deposition rate and also lower net weight changes. Additionally, side reactions like formation of H2 gas observed on the cathode surface, which are common in HCl during electroplating and can reduce the efficiency of copper deposition. Therefore, copper sulfate electrolytes result in higher weight changes due to more effective, less predominant side reactions and also more focused copper electroplating. In conclusion, the electroplating mechanism in this experiment is that the copper anode corroded through oxidation, maintaining the copper ions concentration in the electrolyte and transfer electrons to the cathode, while copper metal was deposited onto the cathode through reduction. However, based on the table, the differences in changes in weight of the cathode and anode was larger in the copper sulfate electrolytes compared to HCl electrolytes due to the presence of cation used for metal plating. Hence, it is better to use copper sulfate solution in copper electroplating due to its effectiveness in depositing copper onto the cathode. As for the recommendation to improve this experiment, the power supply could be used for continuous supply of power and a higher current could be applied to the cell, which will increase the amount of plated metal. Next, a higher concentration of metal ions in electrolyte and a bigger anode surface area are also preferable to improve the efficiency and rate of electroplating. This will lead to a thicker metal plating because the number of oxidized copper will increase and also the number of copper metal deposited on the cathode will also increase. That's all from our group. Thank you very much.